All right, thank you to the three speakers. Can I ask Stefanie and Faez to also join us up here for quick questions before we move to the active portion of our session? Does anyone have a question from the audience? I guess we can ask again your question, but does anyone have a different question? I'll go to Andy. So go ahead. Yeah, please. Or I can repeat it, whatever you're...
Very cool talks. I'm wondering what you guys think is the role of generative AI in the future. I say this as somebody who's working in this space, so full disclosure, I'm guilty too of what these technologies right now use a lot of computational power and a lot of energy and are going to have a large carbon footprint. So where do you think how should we reconcile the cost versus the benefit of these different technologies in the future?
I'm just going to, beautiful question. I'm just going to repeat, how do we reconcile the costs, especially the environmental and economic costs of running generative AI, training and running generative AI models versus the benefits today and in the future? How do you think about that?
Rafael, you want to go? I can go.
I mean, I would say for us, the user base is very small. Like there's 20 companies that make chemicals. So actually there's not going to be, I think this is more sort of a question for sort of, and I fully agree. I mean, my answer to that is like we need better chips, right? Like we need more efficient algorithms or we need faster chips, right? So I think there is a material science, wearing my material science hat, there is a material science question answer to that. But in terms of, generative design in chemistry, the footprints of training might be big, but again, if a clinical trial is going to cost $200 million, you spend $10 million in compute, well, if it really helps downstream, it's not crazy, right? So I would say it has to do more with sort of more commoditized users, maybe.
Yep. Yeah, and I think just adding to that answer, right now we are not at a stage where most of our data sets, cost is directly proportional to the data set size. We are not at 10 billions and trillions. We are at 10,000s, and like most decent workstations can run our deep generative models. I think the cost, one thing which I see in fact as an opportunity is that right now, when I talk to some of these large companies who are running CFD simulations, each simulation runs for weeks. What if we can, and then they throw all the solutions away and start from scratch? What if we create those data sets and in fact offset that cost by using generative models? So I would say right now there's an opportunity to save computation cost. Once we reach the stage where we have text and images, which I don't think is going to happen anytime soon, we might worry about that problem also.
Stefanie, you want to add
it?
Okay. Beautiful.
What a Gen AI previous.
Any other questions? Yes, please.
So what I'm curious about is that to use generative AI in different projects, we pretty much need to bring in people already with AI exposure, or find that the team members can ramp up pretty quickly on the knowledge. And if so, what kind of resources are they using to develop this knowledge and exposure quickly?
So I'll just repeat the questions and tell me if I got this right. So there's a perception that generative AI has potential in many different fields, including fields outside of traditional sort of AI computer science fields. How are you working in different sort of disciplinary domains and in different departments, bringing that knowledge into your research? What kinds of resources and tools are you using? Maybe I'll add sort of what do you think the future is for training graduate students and researchers to use these tools appropriately and creatively in their different fields?
Yeah, maybe I could take that one. So I do not have a background in generative AI, and I'm so busy I would not have the time to learn everything myself. So my way to go about it is to hire students who have a background in generative AI, right? So I just admitted Demircan, who was somewhere in the audience over there. I'm not sure if he's still there. Yep, so he has a background in AI, and I'm really excited that he will join my lab. So through the discussions, I can learn more about, what are the potentials. And I already have somebody in my lab, Faraz Farouqi, who's an amazing PhD student. He already came in with a ML AI background. So for me, it's always this mix of my expertise in research and everything I've learned over the last, many, many years, and the new students coming in with their expertise where they learn the stuff, probably in classes, or just through their own side projects. But I'm not involved in training those folks. So I'm not sure if anybody here is involved. You probably with your class, right? So
yeah. So I think one thing I've observed in my short span of 3 years is that the distribution is shifting. So early on, at least the application pool we get in mechanical engineering, there are fewer students who have done AI, and we are seeing more and more students who have AI experience now. And more students are taking classes which have AI, which is, I think, a good thing. In terms of training, we get in my group, I'm not like I only hire people who know generative AI. There is a distribution. People learn on the job by working on projects, but then some come in with like very high level of expertise. And some are like really good at hands-on projects or mechanical engineering fundamentals. So there's a distribution. One kind of lucky thing is there's so much resources out there on the internet and like online free courses that it's very easy for people to self-learn these days.
Rafa, do you want to add anything?
Maybe, I think there is with deep learning in general, it's moving so fast. There is kind of tabula rasa every 3 or 4 years. So onboarding is always equally easy or equally hard, right? Like if you blink and 3 years go by, like experts need to retrain themselves. So I think it's been sort of welcoming for onboarding at any given time. And then I think on the mathematical and computation side, I think people that come from theory and physics and simulations, it's linear algebra with a different flavor. So I think there's been a lot of folks that came with a simulation background that really sort of translated their skills into sort of whatever AI, generative AI was that year, 2022, 2023, 2024. They segged easily because AI moved very fast, but also their own sort of fundamentals were in sync with what they needed. So that's, I think, what's been the entry point in science and engineering.
Could be a very interesting, longer conversation, but let's stop here. Let's give our 3 speakers a round of applause. Thank you so much.